Okay, class, welcome to Unit 3B. It's a continuation of what we did before, and you'll see towards the end of the unit how we connect the transformations to what we're going to study for the next 2 weeks, trigonometry. And actually, Unit 4 is also going to be about trigonometry, so we're going to spend the next probably 4 weeks on trigonometry. Okay, so we're going to find the trig values on the unit circle, or using what we know from a right triangle using Pythagorean theorem. So, here's my angle theta, and I always draw theta from my positive x-axis. Here's my opposite, my adjacent, my hypotenuse. And let's go through what are the trig ratios using a right triangle. Well, hopefully you do remember the little expression for a right triangle from geometry class, SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I'll write those out. And cosine and finally tangent. All these you should be familiar with. Well, so how do I apply this to the unit circle? Well, I apply it to the unit circle by looking at, I have a radius of 1 for a unit circle. And if you look carefully, there is a right triangle right here, which means this is the opposite side, this is the adjacent side, and this is the hypotenuse. So when I do it in the unit circle, opposite over hypotenuse is just 1 over y. Adjacent over hypotenuse is x over, sine is opposite over hypotenuse is y over 1, adjacent is x over 1, and the tangent is going to be opposite over adjacent, or y over x. Well, I'm not going to leave it as y over 1, I'm going to call it y, and x over 1 is x. So if I look really carefully, tangent is just really y over x, or sine over cosine. So going back to my picture, every point on this unit circle is an x and y coordinate. Well, I think we just decided that x is the cosine value and y is the sine value. So every point on the circle is going to be cosine comma sine, and I'll make it easy for you. It's alphabetical. X comes before y, and cosine comes before sine. So that's doing sine, cosine, and tangent in a right triangle, and there is a hidden right triangle inside of the unit circle, and we get our ratios from the unit circle. X is cosine, y is sine, and tangent is y over x. So let's see what it means when there are 3 more trig functions, and maybe you saw them last year, maybe you didn't. The other 3 trig functions are secant, cosecant, and cotangent, and these 3 guys, these 3 are what we call the reciprocal functions. These are the reciprocal functions because all you have to do is flip a fraction. So what do I mean by flipping a fraction, and which one goes with which? Well, sine goes with cosecant. They are reciprocals of each other. So cosecant, which is abbreviated CSC, is really 1 over sine of theta. And cosine goes with secant. Secant is SEC. So secant is 1 over cosine theta. And tangent goes with cotangent. And this is, so cotangent COT is 1 over tangent of theta. And how do we remember? The way I remember it is a cofunction does not go with another cofunction. So cosine and cosecant do not go together. It's sine and cosecant and secant and cosine. So an S function goes with a cofunction. Sine with an S goes with a cosecant. Well, I'm going to use the same trig ratios that I had before. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. And tangent is opposite over adjacent, so cotangent is adjacent over opposite, and I can write those out. Hypotenuse over opposite. Hypotenuse over adjacent. And adjacent over opposite. If I look carefully then, all these guys I had up here in pink all get flipped upside down, so y over 1 becomes 1 over y for cosecant. X over 1 becomes 1 over x for secant, and cotangent becomes x over y, but x over y is just really cosine over sine. So that's basically the way we're going to figure out our three trig functions, and then our other 3 trig functions for a total of 6. So let's look at our unit circle, get some ideas. We just said every x and y was cosine theta sine theta, and we also discussed that tangent of theta is equal to y over x, which is equal to sine of theta over cosine of theta. That's what tangent is. But I think we also notice that y over x, there's another idea, y over x, that we've talked about many times, and that's slope. Tangent, and we already talked about it in Unit 2, we drew slopes of tangent lines. They kind of go hand in hand. Now when looking at this picture, we always start here. Our positive x-axis is 0 degrees. And when we go counterclockwise, these are positive angles. So this is 90 degrees, 180 degrees, 270 degrees, 360 degrees. But when I go clockwise, these are negative angles. So this is negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 360 degrees, and so on and so forth. The other thing we have to pay attention to is that if you do an angle theta and you add or subtract 360, a full circle to it, you are in the same location. So if I ever give you an angle that you don't like, let's say 540 degrees, I could just subtract 360 to get 180 degrees. Okay, so this is basically what our picture looks like of a unit circle with some angles. We'll do some of the values in a minute, but I want to take this picture and talk about what I have with the 4 quadrants. So as you can see, I labeled my 4 quadrants with what the x and y values are. So in quadrant 1, I have x and y that are positive. Well, I'll do it in order. Sine is the y value, which is positive. Cosine, which is the x value, is also positive. And that means tangent, which is y over x, also has to be positive. That means when I'm in quadrant 1, all of my functions are positive, including cosecant, secant, and cotangent, because when you take a number and you flip it upside down, you take a reciprocal, you don't change positive to negative. A reciprocal does not make things positive to negative or negative to positive. So when I'm in quadrant 2, Let me go back. All of them are positive. When I'm in quadrant 2, sine is the y value. It is positive. Cosine is the x value, which is negative. And tangent, which is the y over x, is positive over negative. It's also a negative value. So when I'm in quadrant 2, sine is positive, so I put an S here. Now notice I do the sine before cosine, because if you look on your calculator, the sine key is before the cosine key. We'll talk about that on another day why. Go to quadrant 3. Sine the y value is negative. Cosine the x value is negative. And tangent the y over the x is negative over a negative, which is a positive number. So only tangent is positive in quadrant 3. I put a T there. And finally in quadrant 4, sine the y value is negative. Cosine the x value is positive. Tangent the y over x is going to be negative. So only cosine is positive. I'm going to put a C here. I have a little expression right over here. All students take calculus. That's how I remember which function is positive in what quadrant. In quadrant 1, all functions are positive. In quadrant 2, sine is positive, which implies cosecant is positive. In quadrant 3, tangent is positive, which means also cotangent is positive. And in quadrant 4, cosine is positive, which means secant is also positive. So my all students take calculus is a little mnemonic device for me to remember which one out of the main 3 trig functions, sine, cosine, tangent, is positive in which quadrant. We've got to know our quadrants. Okay, so we're going to use our little unit circle to figure out the answer to all these questions here, and everyone's going to be either 0, 1, -1, or undefined. So let's put some points here. This point here, because my radius is 1, is 1, 0. This point right here is 0, 1. This point right here is -1, 0. And this point down here is 0, -1. That's going to help me because my cosine is my x value, and at 90 degrees, which is way up here. Remember, positive angles go counterclockwise, negative angles go clockwise. 90 degrees is at the top of the circle. My x value is 0. Secant is going to be the reciprocal, so it's going to be 1 over the x value, because cosine goes with secant. And over here, the x value at 0 degrees is going to be 1 over 1. So my answer is 1. Sine is the y value, so I go to 270 degrees, and the y value there is -1. Cosecant, I'm going to change colors. Cosecant goes with sine, so sine is y, so cosecant will be 1 over y. And at 180 degrees, my y value is 0, so this is 1 over 0, so this is undefined. Tangent is y over x, or the slope. If I come here at 180 degrees, if I draw this line, the slope of this line is 0, or if you want to do the y over x, it'd be 0 over -1. Either way, you get 0. Cotangent of 0, or cotangent, goes with tangent, so it's a reciprocal tangent. It's the x over the y. If I do x over the y, I get 1 over 0, and that is undefined. 90 degrees is going backwards, so if I don't like this angle, I can always add 360 to it. If you add 360 to it, you get positive 270 degrees. Change my color to pink. So this is the y value at 270 degrees, and that is -1. Again, this angle, if you don't like it, you can subtract 360, and guess what? You also get 270 degrees again. The y value at 270 degrees is -1. And if you don't like this angle, you could add 360. You get -180. If you still don't like this, you could add 360 again. Then you get positive 180 degrees. And the x value at positive 180 degrees is -1. So that's how I do these values. Now I'm going to refer to this picture to figure out which is what's going on over here. Again, I don't like this angle. I subtract 360, I get 80 degrees. And sine is the y value, so I try to find where 80 degrees is. Well, I know 90 degrees is here, and this is 0 degrees. So I'm going to guess that this here angle here is 80 degrees. The y value at 80 degrees is f. Well, cosecant is going to be, goes with sine, so it's going to be 1 over y. Again, I'm not a big fan of this angle, so I add 360. I get 50 degrees, and I'm going to guess 50 degrees is this point right here. So 1 over all y would be 1 over d. Cosine is the x value, so the x value at 0 degrees is a. Secant is going to go with, I'm going to change the pink, it's going to go with cosine. So it's going to be 1 over x, and at 80 degrees, that's e, so this is 1 over e. Tangent is just the y over the x. So I go to 50 degrees, and y over x is d over c. Cotangent is the other way around. It's going to be x over y because it's a reciprocal of tangent. I'm not a big fan of this angle. I add 360, I get 80 degrees. I go to 80 degrees. And when I do x over y, I get e over f. And this angle here, again, I decided I'm not a big fan of this, so I'm like, well, take away 360, I get 720. Take away 360 again, I get 360. You can leave it as 360, you can make it 0. And this is the y value at 0. That is the letter B. And this angle, I could add 360, I get negative 310. If I don't like that, I could add 360 again, I get 50 degrees. And the x value at 50 degrees is the letter C. So I'm going to figure out all 6 trig functions for this angle, and I always put this angle from the positive x. So I'm going to give you 2 sides. How do you find 3 sides of a triangle? I use Pythagorean theorem. A squared plus b squared is equal to c squared. Okay? So for this one, I notice I have side A, side B, and I don't know c. So I do 4 squared plus 3 squared is equal to c squared. And I figure out that c squared is 25, or my missing side is 5. And I would hope you know that a 3, 4, 5 right triangle is the most famous right triangle. So once I have that missing side, I could do all 6 trig functions. I tend to do sine first, so sine of theta is opposite over adjacent, or 4 over 5, which means cosecant is its reciprocal, 5 over 4. Cosine of theta is adjacent over hypotenuse, 3 over 5. That means secant is its reciprocal, 5 over 3. And tangent of theta is opposite over adjacent, and cotangent is its reciprocal. And I get these results. Now, when you do Pythagorean theorem, the missing side is not always the hypotenuse. You're not always solving for C. So in this case, I have my A value. I don't have a B value. I have my C value of 13. So I have 5 squared plus B squared is equal to 13 squared. I'm going to solve for B. B squared is 144, or B is equal to 12. So this missing side is 12. 5, 12, 13 is another nice little right triangle. So when I write out this whole thing out, sine of theta is opposite over hypotenuse, and cosecant is its reciprocal. Cosine of theta is adjacent over hypotenuse, and secant is its reciprocal. And tangent of theta is opposite over adjacent, and cotangent is its reciprocal. Okay, and there are all 6 trig functions. Okay, these next 2 problems are going to be very similar to what I just did on the previous page, except the problem is I have to draw my own right triangle and again use Pythagorean theorem to figure out what I don't know. Oops. I'm going to spell things correctly. Here's my eraser. Can't even see this. Pythagorean theorem. So when I see this problem, I see sine, and sine is just opposite over hypotenuse. So I'm going to draw a right triangle. I always put theta here. Opposite side is 3, hypotenuse is 7, so I had to figure out the missing side. So right now I have 3 squared plus b squared is equal to 7 squared, and I kind of do things mentally. I see it as this, I subtract, and I get the missing side is that. And just leave it as a radical. It doesn't matter, I don't want you to clean things up. So when I do use a Pythagorean theorem, if I have 2 legs, I square them and add them. And if I have a hypotenuse in a leg, I square them and subtract them. So now I have all 3 sides. And I could do all my functions. Well, I already was given sine of theta was 3 over 7. So cosecant, its reciprocal, was 7 over 3. I didn't even have to do the right triangle for that one. Cosine is going to be adjacent over hypotenuse, and secant is its reciprocal, and I don't care about the radicals in the denominator. They don't bother me. And tangent is going to be opposite over adjacent, and cotangent is its reciprocal, and I get those 6 trig functions. Next problem, I'm going to draw my triangle. Here's my theta. Tangent is opposite over adjacent. So this is 5, this is 9. I do not know side C. So I'm going to do 5 squared plus 9 squared is equal to C squared. And I get 106 is equal to C squared, or C is equal to the square root of 106. Just leave it as a radical. So I was given tangent first of all, so I'm going to use that to begin with. And its reciprocal cotangent is 9 over 5. Then I'm going to do sine, which is opposite over hypotenuse, and its reciprocal cosecant is just the same fraction but flip upside down. And then I have cosine, which is adjacent over hypotenuse, and secant is its reciprocal, which is over 9. Okay. And those are those 6. So for these next 2 problems, well, again, I think I'm going to have to draw a triangle. I'm going to use Pythagorean theorem, probably. But the other thing I have to do is figure out what quadrant I'm in. The other problems, I didn't really care about the quadrant because everything was quadrant 1. But I had to play the quadrant game. How do I play the quadrant game? Let's see. I'm given this information. I'm given this information. Well, if it's cotangent, it's really tangent. So the 2 pieces of information I'm given is that cosine is positive and tangent is negative. So according to my information, I'm in quadrant 4. And I'll use that later. I'm going to draw my triangle. Well, cosine is adjacent over hypotenuse. So when I draw my triangle, I get theta's here, adjacent is 2, hypotenuse is 3, I don't know side A, and I use my Pythagorean theorem. And I just square 3, which is 9, I square 2, which is 4, I subtract them, and I get A is equal to radical 5. Just leave it as a radical. And I don't have to find everything. It says, give me sine of theta, and give me tangent of theta. Well, according to this triangle, sine is opposite over hypotenuse, is radical 5 over 3. And tangent is opposite over adjacent, which is radical 5 over 2. But now I have to pay attention to my quadrant game. We said this was in Q4. Both of these are in Q4. When I'm in Q4, sine and tangent are both negative. So I have to make them both negative based on this problem being in quadrant 4. Finally, the last one, I'll play the quadrant game. I have sine of theta is equal to negative. Tangent of theta is also equal to a negative. So again, I'm in quadrant 4. That's okay. Draw my triangle. Put my theta here. Do not pay attention to the negative right now. We'll worry about the negative later with the quadrant. This is opposite over hypotenuse. This is side 1. This is side 4. This is side B. 1 squared plus b squared is equal to 4 squared. 4 squared minus 1 squared, I'm going to get b is equal to the square root of 15. So this is square root of 15. And I have to find cosine of theta. I have to find cotangent of theta. Well, cosine is adjacent over hypotenuse, radical 15 over 4. Cotangent is flipped of tangent, so tangent is opposite over adjacent, so cotangent is adjacent over opposite, which is radical 15 over 1. I'm not going to write the over 1. But now I have to pay attention to my quadrants. We're in Q4. Cosine is positive in Q4. That's good. But this one in Q4, cotangent, which goes with tangent, is negative. So these are negative results. That one's a negative result. And there you go. Thank you for watching this video.